Okay, so in this problem here, as you've asked me to look at, so here are our differential equations here, and we also know that 400, but it's measured in 100, so this is actually 4, and this is actually 3. And if it's less than 0.01, then the population is extinct. So what does that actually mean? Well, when I take these particular differential equations and I put them into Euler's method, I come up with these particular forms in and so this here is what I'm looking for x. This is my y. Simplified, I could use the other originals, and this is my t. And then I come along and I put it into my calculator. And this is how I'll put in my calculator n min at 0. That's our starting n value. 4 for my n min, 3 for my v min, and my w min is 0. And I type it in as this. When I was looking at the answer sheet, they were talking about doing it in a spreadsheet, especially because I have to go up to n is 20, and that's when x goes below 0.01, so x gets extinct when n equals 20. And so now when I go to B part, I hope that helps with your calculator issues. I am a little frustrated that calculators are having a hard time doing these equations. I bet you're frustrated too. So then when it comes to B part, it says write down the differential equations for the population of y if x becomes extinct. Well, if I'm looking for the differential equation for y, I'm only looking at this. And if x is extinct, that means x equals 0. And so then I come up with the equation, let me change colors, that dy dt is equal to 3y. And this hopefully you recognize as exponential growth. By this point, you've done enough of them. And in order to solve that scenario, write down an equation for this. In order to solve that, this is a separable differential equation. So I'm going to divide by y, dy, integral is going to equal to 3 dt. And so when I solve this, I get ln y is equal to 3 t plus c. Y is equal to e to the 3t times e to the c. This here is just some constant, so y is equal to c e to the 3t, and that is going to be my population growth equation, and that's part B. I guess to be true to the equation, it says to make that value a because it's the initial population, and so we'll call it a.